Hello, today we are going to study about the rise of AI agents that we are seeing in 2025, and we are going to study all the history as well to conclude and also get to know why we are actually building these AI agents and automation and why it's so popular. So let's start with the little bit of history. That is, in 2022 we saw the rise of LLMs, where we all were using different LLMs like ChatGPT, Gemini, and all the things which were coming out. And then we saw the rise of compound systems or compound AI systems, where we see the multiple augmented generation and other such kind of systems used by companies and experts. And now since 2024 we are seeing the rise of AI agents. So let's get deep into it about this example. So if you want to go on a summer vacation and you just ask an LLM about it, for example, you ask how many vacation days do I have left. So the basic LLM approach in response will be I'm not sure. That depends on your company's policy, as you can see in the chat. Sorry, in the screen on the screen. So why the LLM is acting like this, or why it's saying that? Because the reason is simple. It doesn't have access to your database or your knowledge base, which holds all the information regarding your holidays. So obviously it's not gonna answer. So that was the issue with LLMs, that it is trained on some general data, that it can solve general problems but not compound or some niche related problems. That's why we see the compound AI systems. So basically what did compound AI systems did? From models to compound AI systems, what happened? We realized that we need some more niche specific LLMs that could answer queries based on the database or some knowledge base we provide them. So that's the one of the reasons why we went from normal LLMs to compound AI systems. And in these compound AI systems, we actually use the system design approach that we use in software engineering as well to build scalable systems. And what happened is that models on their own, as you know, can't learn everything because they have limited training data. So what we did, we attached them to our knowledge base using vector databases. As you can see that we made some RAG systems that help LLMs to actually access our personal data, and then based on that they could give us a better solution. So the benefits of this is are the benefits were that it has now access to our knowledge base as well. It is more adaptable and it delivers little bit accurate answers regarding. So now if you ask the same query that we were asking, that how many days I can take my leave, so if it has access to your HR's knowledge base, it can actually give you a response. But now what happened, we also reached some now. So as we need more complex solutions, more complex answers, so to complex solutions, we needed an LLM agents that could actually do three things. First is reasoning. We don't want them to quickly give us an answer. We want them to reason it. We want them to plan the query and how they're gonna execute it. So we want them to take time instead of just quickly giving us answers. And that's why the three components that actually should be present in your agent is that reasoning. First of all, it should take some time. It should identify the problem, it should plan it, then take actions. So now what is actions? So in this action phase, what we actually want is that we want the AI agent to have an external access to different tools. For example, it may be a calculator, it may be access to an API from where it fetches some backend data, or it could be access to search engine, so that it can use those tools if needed, not mandatory, if needed. And then the access to a memory as well, because there we will be storing it, then we're gonna accessing it those memories if we need in future. So for example, if I ask it a query that where should I visit this when should I take the my remaining vacation leaves in this summer vacation, and where should I go, and if I wanted to go somewhere, how much uh, it's gonna cost me. So example like this, where we are trying to solve a complex problem, not just one question, it has 3 to 4 questions. Actually, I'm trying to get a whole tourism guide from an agent. So here it will first do the reasoning. That means it's gonna plan the everything. Then for to find out the where's the best time to visit a beach, it will go on the it can access any weather API to find out if it's a good day to visit a beach on that day or not, or all the hotel discounts and everything. So this is something that's a very complex problem, and we need a solution to it. So that's why it should have 3 things. Now, as I said earlier, an agent should be comprised of 3 things, that is an LLM, obviously, a tools, and a memory. So if you are making any AI agent, it should have these 3 systems, because as you could see on the screen, from one big model to systems that act, adapt, and remember. We want to go from programmatic approach to an agentic approach, and that's why we did it. Now let's go in little bit depth about what is this. The concept we use while developing this type of AI agent is called react, reasoning, and acting. So as you can see, it's one of the most popular frameworks for conferring AI agents, and as I already explained you, it works on 3 principles. First of all is reason. That means just like we humans work, first we plan something rather than just uh, quickly getting answer. We plan something, we take our notes, and then based on that plans, it can act. For what in the act means that as a human, if you ask me to create a tourism guide for you, first of all I will ask you questions. Then what I will, after getting the data, I will plan it accordingly. Then I will go on Google search or any other search engine, or any other place to get all the details. And after that, the one more thing, and this one is also important, after that I will observe. So as you can see, after preparing a tourism guide, I will observe it. Is it good? Is it perfect? If it's not, I will reiterate and then do the process again. As you can see here, we tried to create a tool that should have all these functionalities. So basically it will have 3 core components, that will be first to observe, to actually plan, the reasoning, the action, the in which it will use tools to access all the information, and the memory. But the fourth thing will be it should observe, because it's a basic thing. So your AI agent should be capable of doing this as well. All right. Now let's understand this with a simple example. So I name this as sunscreen problem, and what we're going to do is that how the AI agent gonna tackle this question. So my question is, how many 2-ounce sunscreen bottles should I bring for my Florida vacation next month? I'll be outdoors a lot and I am prone to burning. So if you ask this to the AI agent, it should first of all work in these scenarios. First of all, it requires multiple steps and information sources to solve properly. That's actually true. We need multiple sources to solve this complex query. So first, it will go to this. It will gonna retrieve vacation duration. First of all, it gonna go to the knowledge base. Of course, it should know how many days of vacation I have. So it should know, right? Second, it gonna research sun exposure. Check weather forecast for Florida next month to estimate average daily sun hours. Obviously, it's gonna go access the weather APIs or search engine to find this. Find recommended dosage. Search public health resources for sunscreen application recommendation based on skin type. Next, the fourth part is calculate total needed multiple days into hours into recommended dosage and convert to number of 2-ounce bottles. So by doing all these steps, it will give me an output that will be my solution. So this is how we need to develop our AI agents. All right, now let's go to the last part, that is the future balancing autonomy and efficiency. Now, as you can see, we are developing a lot of AI and automations and using AI agents for multiple use cases. So compound AI systems are here to stay. First of all, it started with LLMs, as I told you earlier, but now we have moved from just using LLMs to actually integrating into systems that could scale and find and could give the answer for complex problems, as we saw in the previous example. Now, for that, first you need to understand that first we were using just a programmatic flow. So if you go and check any RAG application, the flow chart of RAG is simple. It first goes to a vector DB, it fetches the query, and it fetches the search query, then it passes the search query to LLMs, and then it gives the output. So it was pretty basic, but now we move towards agentic approach where it plans, thinks, and instead of just retrieving things faster, it takes time to give us perfect examples. And these things are gonna stay, and obviously we are going to see more hybrid future as well by applying this agentic behavior with our combined system design and developing more systems that will be beneficial for everyone else. And this is it, this is the like overview of what are AI agents, and this is why you should also invest your time in learning and building AI agents. Next time we will be tried building a simple AI agent that will try to create LinkedIn AI post, and we will build it, and it will be super easy. It will be like level 1 AI agent which doesn't have all the three components, just basic, so that anyone can start with developing their own AI agents, coding it through the code, not no low code or no code tools. We are just going to make it, and then we move on to the next part of these things. Thank you.